Climate change is causing extreme weather events on a massive scale. Historic buildings and archaeological sites are hugely important to our society and are especially susceptible to damage from increasingly common natural disasters such as flooding. That's why engineers are coming up with new ways to protect and safeguard these vulnerable buildings, conserving our priceless cultural heritage and making sure we don't lose our links to the past. That's why I'm an engineer.
I'm Harriet.
I am Viviana. We are sound engineers and we both love our job.
In my research, I look at how buildings are made to see whether they'll fall down in future earthquakes.
I specialize in vulnerability of historical buildings using analytic methods, computer models and artificial intelligence to identify how buildings behave under seismic events.
It's really important to understand where earthquakes will cause the most damage so that projects to protect people can focus on the areas most in need.
There are so many challenges to be faced every day. Being an engineer pushed me out of my comfort zone, doing things I would never thought I would do.
An engineering career can involve many different types of work, and no 2 days are ever the same. I'm really proud to be an engineer.
As earthquake engineers, we want to ensure that people and buildings are protected from the unpredictable. We've all travelled around the world and seen firsthand the devastation that earthquakes can leave behind. Our aim is to try to prevent this.
Before carrying out any simulation analysis, we need to go on site and check how the building is by taking measurements for the geometry and the materials. We can even extract pieces from the structures and test the material properties in the lab. Or where we want to measure the crack propagation, we can either use cameras or fiber optics.
Nowadays, we can realistically simulate a building's response to earthquakes, storms and other natural hazards with computer simulations, using all the information we collect to develop models of the buildings. With these simulations, engineers like us develop strategies to protect the buildings and, most importantly, to protect the people that use them.
Most people don't realise how even the littlest effects of natural hazards, things like small earthquake tremors, localised flooding and volcanic ashfall, can all add up, affecting people's lives and infrastructure, from things like power and water networks to systems like healthcare and transport. I started out studying geology at university and moved into engineering when I became interested in the long duration hazards and their effects on infrastructure. I've worked in Montserrat in the West Indies, where the eruption of the Soufriere Hills volcano has been ongoing since 1995. People there have lived with the threats to their infrastructure and livelihoods for nearly 20 years. As engineers, we need to understand how society and social infrastructure are affected by natural hazards so that we can reduce risks and enable people to live their lives. That's what engineers do.